Okay, so no more talking. You shouldn't have earbuds in, any of that stuff. So what we're going to be working with are something called systems. And we're going to work on these for a while. There's 3 different methods to solving a system: graphing, substitution, and elimination. And what a system is just 2 or more equations. So like if you look at the back, you'll see that's an example. These are examples of systems. Okay, just 2 or more equations. For right now, we're just doing 2. And so how we find the solution to a system with graphing is different than we do the other 2 methods that I mentioned. But all 3 methods, you should always get an ordered pair as your solution. Ordered pair, which is just xy, right? It's just a point. So you need a point. So on a graph, it's where they cross or intersect. Dylan, put that away and write some notes, please. You could call it where they cross. So the whole idea here is we're going to Yep, I'm digging in the garbage. Don't mind me. Okay, so what we're going to be doing with this type of system is we're going to put them in slope-intercept form if they're not, and then put them on the graph. And we need graph paper for this because it has to be exact. And then wherever they cross is the solution. So I'm going to make up a problem. I'm not even going to actually do slope-intercept form or anything. And go ahead and sketch it with me. You basically, I'm going to have them cross at this point. And it doesn't matter where the lines are perfectly. I just want you guys to show where the 2 lines cross, okay? And mine are crossing at 0, too. So it could be a little different than mine. So let's pretend we put 2 equations in slope-intercept form, we graph them, and then we have to say what is the solution. So what you're doing is finding where they intersect or cross. And that would be the solution, okay? So in this case, that point is 0, 2. That's the solution. Now there's another way of saying what the answer is, and there's going to be 3 choices, and I'm going to do one of each type here. You can have no solutions, infinitely many solutions, or you can have 1 solution, which is what we have here. We have 1 solution. When you have 1 solution, you say that your system is independent. That's what we say for classifying. Independent. And the way I help myself remember these, because in a minute we're going to have a total of 3 different classifications, is I'm going to give you like a little thing to help you remember each one. So the way I think of independent is we have 2 lines going in different directions. They're independent. Like you are independent of your brother or your sister or your parents. You go your own way. So 2 lines that go 2 different directions are independent. Okay? And that's going to make a lot more sense when I give you the other 2 types. Okay? All right, so let's pretend we have 2 lines that don't intersect. What's another word for that? 2 lines that won't intersect. Parallel, right? So just roughly graph. It doesn't have to be perfect. Less. Okay, so if 2 lines don't intersect, how do I answer this? The solution is wherever they cross. Where do they cross? Nowhere. So so it would be no solution. No solution. And another way of writing no solution is like the fancy brackets with like a 0 inside. I just think it's easier to write no solution. And the classification of that is inconsistent. Well, it doesn't make any sense. How can we solve a system when they don't even touch? It's inconsistent. That's what we classify it. Okay? So 2 lines that don't intersect, aka parallel lines, have no solution, and they're called inconsistent. And the last type is where 2 lines are the same. So I graph a line, okay, I do my M and B, and we're going to actually do the graphing part here in a second. I graph a line, and then I graph the same line right on top of it. It's the same exact M and the same exact B. Where do they touch? Everywhere, right? This line and this line, they are intersecting or touching or crossing everywhere. So we say infinitely. Okay, I'm going to spell it out the first time, then you can abbreviate it. Infinitely many solutions. Why not say, well, let me back up. Infinite means it goes on forever, right? We know that these arrows are pointing towards infinity. So there's so many solutions. We could never name them all. But why don't I say all real numbers? Is this a solution right here? No. So it's not every number. It's just all the numbers that they have in common, all the ordered pairs, which is an infinite number, right? Because it goes on forever in both directions. This is the one that everyone gets confused with that first example. It's dependent. And I have a way to help you remember the difference between independent and dependent. So most of you probably have a friend. Don't say names. So I usually use this because I hear you guys talking and stuff. Like you have a friend who's always with their girlfriend or boyfriend. They're dependent on each other. They're always together. They're like, they have to be sitting together at lunch. They have to sit next to each other in class or whatever. Even if you don't have a friend like that, who cares? You get the idea. These two lines are dependent on each other. They can't be apart. Dependent on each other. And then back to this one, independent. They go their own way. They don't need to be together all the time. Independent, dependent, inconsistent. Okay? I don't know if that helps. Maybe it will. Maybe you just memorize things easily. I just don't. Okay. So let's actually do some with the graphing. Okay? So one of these three situations every time. So we get lucky sometimes, and our equations are already in slope-intercept form for us. Okay? And we did do slope-intercept form in this class, but if you need to do this, I don't require it, but if it helps you to identify the M and the B for each of these, just to get like your thoughts organized, you're more than welcome to. Remember, slope should always be a fraction. So if it's a 2, you can think of it as 2 over 1. And B is negative 4. So let's just start with that. Go ahead and draw yourself an X and Y axis. And this is where you want to be careful. Sometimes I'm like, just sketch a graph, doesn't have to be careful. If you're looking for where 2 points touch, you need to graph as carefully as you can. Okay? So I'm going to graph my B first, which is 1, 2, 3, negative 4. Remember, your first point always goes on the y-axis. Always. Every single time you graph, your first point should always go there. From that point, we graph our slope. Since it's positive, it's going to go like this. So I can go up to right 1 or left to down 1. Either way, doesn't matter. So up to right 1, up to right 1, and so on, down to left 1. The more points you give yourself, the more accurate your line will be. The easier it will be to connect the points. So we really say you only need 2 points to make a line. When I'm doing something like this, I am a little bit more careful. Okay? And I think you're going to find that this is pretty simple. You'll see these all cross at nice places, not decimals and stuff like that. All right, so I graphed this one in blue. I'll graph this one. Oh, we didn't pull up the M and the B. So M would be negative 1/2. It's already a fraction. And B is 1. So I'll do this one in red. Always graph B first. B is your y-intercept. So 1. And it's a negative slope, so it's going to go like this, right? So I can go down 1, right 2. And you can see I already found the point where they cross. See where? So I don't really have to give myself a whole bunch more points now. I can see the place where they crossed. Because remember, wherever they cross, that is your solution. You just have to name the point. What's that point? No, 2, 0. Close. Careful. We go to the right 2, up, down, 0. And how do we classify this one? Yes, independent. And you can abbreviate. I'm all about abbreviations. I'm all about sticky notes and abbreviation. Independent. Going their own way. I'm going this way, you go this way. We don't need to be together all the time. Did we understand that? Anybody have a question? Okay. Okay, we got lucky again. Look, it's slope-intercept form. We don't have to rearrange it like we did yesterday. Remember we did that yesterday. So M is 3/4. B is 2, right? I'll do that one in blue. Let's just go ahead and find this one. And in this one, M is also 3/4, but B is negative 2. You should already be able to tell maybe what this is going to look like. Whenever you have the same slope in different y-intercepts, does anybody know what happens? Well, let's see. B is 2. Always graph the B first. Positive slope, right? So it should go like this. 1, 2, 3, 1, 2, 3, 4. Let's put one on the other side. 1, 2, 3, 1, 2, 3, 4. B is negative 2. Same slope. 1, 2, 3, 1, 2, 3, 4. What are these? Parallel. So when you have the same slope but different y-intercepts, that makes parallel lines. Okay? They have to have the same slope. They tilt at the same angle. But their y-intercepts, the b value is different. You can see it right here. One's a plus, one's a minus. So the solution here would be none, right? There's no solution. Where do they touch? Nowhere. What would we call it? Classification. Inconsistent. It's like it doesn't make sense. It's a dumb question. How do I solve something that has no solution? Think of it like that. All right, last one. Problem is these are not in slope-intercept form. So sometimes you're going to have to put one or both, sometimes maybe just one, in slope-intercept form. So I'm just going to give myself some space down here and rewrite it. Rewrite both of them since I have to put both of them in slope-intercept form. And this is what we did yesterday. Remember, we first plugged into point-slope form, and then you had to get everybody to the other side. Same idea, same exact idea. What's the first step in this first one? What would I do? Divide all of them by 2. And I get y equals 3x minus 7. I have a slope of 3 over 1, a b of negative 7. What's the first step in the second equation? Yeah, how do I do that, Mandy? What? Minus 3x, really good. Remember, we add or subtract in solving equations first, and then if there's anything to divide, we do. And the order matters, right? We want slope-intercept form, so that's why I put the x value in front of the 7. And what will we divide by in this one? Because y is not by itself. It has to be. You could multiply by -1, but we usually have, like if this was a -2 in front, let's pretend there was a -2 in front of the y, you would divide by -2, right? So just to keep things the same, I'm just dividing by -1. But yeah, was that you, Gabe, that said that? You would get the same answer if you had multiplied. So it would have been okay. Without even graphing, don't we know what the answer is? No. No. Yeah, it's because, look, slopes are the same and y-intercepts are the same. Everything's the same. When you graph it, you're going to have, so you really only have to graph one of them. My b is -7, 1, 2, 3, 4, 5, 6, 7. Up 3, right 1, up 3, right 1. And if we graphed this one, it would be right on top of it, right? So the solution to this one would be infinitely many solutions. What's its classification? Dependent, right? Always have to be together, dependent on each other. I'm just abbreviating because I ran out of room. right? So, guys, I'm giving you a nice, pretty easy 2 days. Today, the worksheet has 10 on it, but you only have to do 5 today. I'm letting you guys do the other 5 on Monday and giving you a chance to use this time to catch up. I know a lot of you missed yesterday. There's other days that you might have missed. If you need to make up a quiz or a test, use the time, okay? If you don't understand something, have me sit with you and go over it. I will, okay? But if you're absent, you first need to watch the video before I'm going to teach you one-on-one, okay? All right, so I'm going to pass out the worksheet. Today is 1 through 5, Monday is 6 through 10, and making up any work that you have, like that. Then listen, I'm going to have a homework check at the end of class on Monday. That gives you time to get caught up on anything you want to get caught up on at the end of class Monday. So go back and finish what you need to do.
Exactly. I said I missed. I couldn't go look at 2 lines. Okay?
I saw you on that. So once it's off of film,
I started doing that and then I realized it was a back.
That is not a saying. That's so good. Oh my God, that's not I just wonderful alien line. Oh my.
this March again,
I'm telling you. Oh, you like little dance stuff? Oh, the street.